Good morning, all. Today we are going to see uh, from your third unit, and that is microprocessor. Right? So we'll see a few basic terminologies which are used there in microprocessor, and then we'll see evolution of how actually microprocessor evolved. Right. So let me share my screen first. Okay. Is it visible? Is my screen visible? Okay. Okay. Thank you. Okay. So we'll start with few terms there, which are we basically use there in microprocessor. I think you gone through those terms earlier. Still, we revise those terms since we are using those terms in your further units, right? So from third to sixth, we are going to use those terms uh, very often. So we'll start with those terms. First term is bit. What is bit? What is bit? Hmm? Now your replies are important. Replies are important for this thing. What is bit? Bit is basically binary digit, right? Binary digit. 50 is from digit and BI is from binary. This is basically bit, right? So bit is a digit of binary number or code, which is called as bit, right? Now, next is nibble. What is nibble? Group of 4 bits, right? Group of 4 bits is called nibble. Byte. Group of how many bits is byte? Group of how many bits is byte? Yes, 8, right? 8 bit is byte. Word. Word is group of 16 bit, right? Group of 16 bit is basically called. Then double word, obviously double than this. So 32 bit. You also call multiple word. So multiple words are there, right? A multiple word, you call it as if it is 64 or 128 and so on. So such type of multiple bits are there, and this is called multiple words, right? So this is basically about bits, or basically it's all about binary data. So how you treat your binary data, how you count your binary data in bits, in nibbles, in bytes, in words, in double word or multiple words. So count your bit and rather binary data in bits and bytes, right? Now, next is about what is basically data is. So what is data? So the amount, or you can say quantity, that is operated by instruction. The quantity that is operated by an instruction is referred as data, right? So the amount, or you can say a quantity of binary codes or binary numbers that is operated by an instruction is referred as data, right? We are in microprocessor context, right? We are in microprocessor context. So uh, the what you say definitions are referred in terms of microprocessor, right? So data is basically a quantity, or you can say a binary number codes quantity, which is operated by an instruction. How you calculate the size of data? Obviously, uh, by using bits, bytes, and words, right? So by using bits, bytes, and words, we can count our data, or we find the size of data, right? So this is what an data is. Now, next is about address. What is address? Hmm? What is address? Location of data. Yes, memory location. Yes, exactly. The address is basically identification number. So address is basically an identification number for memory location. So if you have binary data which is stored at memory location, address is where that is an identification number which actually identifies a memory location, right? So this is basically an address, or this is basically an identification number of memory location, right? So it is all about data, which is you can find your data which is stored in memory by this identification, right? So this is about address. Now, memory word size. Memory word size. What is memory word size? A memory word size is the size of binary information that you can store into memory location. So what is you stored in at the memory location, and the size of that binary information is basically called a memory word size, right? So this is all about data, address, and memory word size. Are you with me? Are you with me? Are you listening all those? No? Okay. No issues. Now next is microprocessor. Now, what is microprocessor is? So it is basically an program control device. Microprocessor is an program controlled device. It is you also called as semiconductor device. So semiconductors are used in these devices, right? So you basically called a microprocessor as a program controlled semiconductor device which can fetch the instruction, decode that instruction, and execute that instruction, right? So microprocessor is a program controlled semiconductor device which can fetch the instructions, and it will decode that instruction and execute that instruction. From where it actually fetches? Obviously from memory, right? So it will fetch the instruction from memory, decode that instruction, what is basic meaning of that instruction that is decoded there, and execute that instruction, right? So it is or that microprocessor basically is used as CPU in computers, right? Microprocessor is used as a CPU in computers. What is CPU? Hmm? What is CPU? Yes, yes. It is central processing unit. So this microprocessor is basically used as central processing unit in computer, right? What all things are there inside this microprocessor? There are certain what we say things available, which is called as ALUs are there. Then register array or registers are there to store information, and then control unit to control all the things or all the instructions. So ALU stands for arithmetic and logic unit, right? Arithmetic and logic unit is basically called as ALU. Registers are for storing information, and control unit is used to control on all operations and all blocks which are present there in microprocessor. So basic idea is whatever your size of ALU is basically a size of microprocessor, right? So if your ALU is of 8-bit, then your microprocessor is called as 8-bit microprocessor, right? If your ALU is of 16-bit, then your microprocessor is called 16-bit microprocessor, right? So ALU is basically identity or rather process or the data which comes to semiconductors. So size of data which is referred by ALU or whatever size which that ALU going to process is referred by bit size there in ALU, and what is that size is referred as that microprocessor size, right? So if my ALU is of 8-bit or my ALU process 8-bit data there, then the size of microprocessor is 8-bit microprocessor, right? So basically 8085 is 8-bit microprocessor, right? Or ALU size of 8085 is 8-bit, so 8085 is called 8-bit microprocessor, and 8086 is 16-bit ALU, right? 8086 is 16-bit ALU, so it is referred as 16-bit microprocessor, right? हे clear झालं का microprocessor related? So microprocessor is basically program controlled semiconductor device. It is used as central processing unit in computers. What is task of microprocessor? It fetches instruction from memory, decode that instruction, and process that instruction, or you can say execute that instruction. What all things are there in your microprocessor? ALUs are there, registers are there, control unit are there. ALU is basically used for data processing, or that is called arithmetic logic unit. Registers are basically called to registers are basically used to store the data near processors, and control unit is used to control all those functional blocks, right? So data processing capacity depends on arithmetic and logic unit. So whatever the size of ALU is treated to be a size of microprocessor. So what is my size of ALU? If my size of ALU is 8-bit, then the microprocessor is treated to be as 8-bit microprocessor. If it is 16-bit ALU, then my microprocessor is treated to be as 16-bit microprocessor, right? So this is basically about basic introduction or brief introduction of microprocessor. हे समजलं? हे समजलं? जाऊयात का पुढं? Okay. Now, another term which is there is called bus, right? So, what is bus? Bus is basically group of conducting lines, right? Group of conducting lines is referred as bus. So that bus is either carries data or it carries address or it carries control signal, right? It carries address or it carries control signal. If my group of conducting lines which carries either data or address or control line, right? Signals, or control signals, you can say. My group of conducting lines either carries data or it carries address or it carries either control lines. Then that group of conducting lines is referred as bus or is called as bus, right? So this is basically about bus. Now their name are depend on what it carries, right? If my bus is carries data, then that bus is called data bus, right? It carries data, right? If my bus is carries data, then that bus is called data bus. If my bus is carries address, then that bus is called address bus. If my buses carries control signal, then that bus is called control bus, right? It carries basically control signal, right? So group of conducting line either which carries data to ALU, address to memory or few control signals to functional blocks, then that group of conducting line is called bus. The type is depends on what it carries. If my bus is carries data, then that bus is called data bus. If my bus carries address, then that data bus is called address bus. And if my buses carries control signal, then that is called control, right? One more term which is used as system bus, right? What is system bus? The definition which is used for bus is basically a system bus. So my conducting line either carries data or address or control signals. If my conducting lines carries data or address or control signal to microprocessor system, then that bus is called system bus, right? If my what we say, if my conducting lines are carries address data or control signal to microprocessor system, then this is called as system bus, right? The basic differences are few there. I'll tell you as and when it comes to your syllabus, right? I'll tell you the differences as and when it comes with flow, right? Uh, but time being, just to keep those terms in your mind. One more is called CPU bus. So the bus which is or conducting lines or group of conducting lines that are directly connected to microprocessors are called CPU bus, right? If the group of conducting lines are directly connected to CPU, then that group of conducting lines or that bus is called as CPU bus, right? So this is basically about bus, right? There are so many type of bus available. इथपर्यंत क्लिअर झालं का? हम्म? Now, one more term which is present over there is clock. क्लॉक म्हणजे काय? क्लॉक म्हणजे काय? मी बोललो होतो परवा काहीतरी क्लॉक रिलेटेड. Okay, let it be. A clock is basically a square wave or a signal, a square wave or a signal which is used to synchronize, which is used to synchronize various devices in microprocessor and in system, right? So clock is basically a square wave which is used to synchronize various devices in microprocessor, right? So every microprocessor requires a clock pulse to synchronize, right? Rather to operate, right? So clock signal should be, a clock should be there in each and every microprocessor to operate, right? To operate, or you can say uh, to what we say to processing, right? So so many questions are there on clock in gate exam as well, right? Gate मध्ये सुद्धा याचे बरेच क्लॉकचे म्हणजे किती क्लॉक फ्रिक्वेन्सीला at how many clock frequency this microprocessor works, how actually clock frequency is applied to microprocessor and all such type of questions are there in gate as well, right? So this is also an important part. So clock is basically a square wave. Even I said that it is a square wave, the signal never goes from low to high in such way, right? असा directly कधी high होत नाही. Still आपण असा square wave दाखवतो clockचा, but basically it is like, right? जरी मी स्क्वेअर वेव्ह म्हटलं तरी तो सिग्नलला काहीतरी टाइम स्पॅन लागतो. दॅट टाइम स्पॅन इज दिस, राईट? जस्ट टू गो फ्रॉम लो टू हाय अँड फ्रॉम high to low. Our time span is required to clock, right? So even though I say that it is square wave, the signal looks like this practically, right? Signal looks like this practically. I already told you that there are two type of triggering, right? Devices चे triggering. कुठल्या कुठल्या टाईपचे triggering असतात? डिव्हाइस कुठल्या कुठल्या टाईपला ट्रिगर होतात? ट्रिगरिंग इज बेसिकली कॉल्ड, तुम्ही आता जनरली स्टार्ट होतात असं म्हणू शकता. ओके, ट्रिगरिंग मी काय सांगितलं होतं, कुठल्या कुठल्या स्टाईलचे ट्रिगरिंग आहेत? अरे बोला रे बाळांनो, तुम्ही बोललात तर कळेल, नाही तर काय सांगितलं होतं मी? See, if I say device is okay triggered, device is triggered म्हणजे काय, तर ते डिव्हाइस त्यावेळेस ट्रिगर होतं म्हणजे इट स्टार्ट्स इट फंक्शनिंग, राईट? त्याचं फंक्शनिंग स्टार्ट करतं ते. तर ते कुठल्या कुठल्या वेने स्टार्ट करतं, तर ते पॉझिटिव्ह एज ट्रिगर्ड असेल. म्हणजे काय, तर सिग्नल इज गोइंग फ्रॉम लो टू हाय किंवा 0 to 1 असेल, दॅट इन दॅट केस इट इज पॉझिटिव्ह ट्रिगरिंग. इफ इट कम्स फ्रॉम हाय टू लो, ही जी स्टाईल आहे डिव्हाइस ट्रिगर होण्याची, दॅट इज कॉल्ड निगेटिव्ह एज ट्रिगरिंग. And one more addition here is level triggering, right? So एका हाय लेवलला किंवा लो लेवलला और stable level असेल, and that in that case if device is triggered, it is called level triggered, right? It is called level triggered device, or it is called level triggered signal, right? So when clock starts functioning or device starts functioning based on clock, then that device either may be positive age triggered, or it may be negative age triggered, or it may be level triggered, right? So this is basically called as triggering. Now, one more important point in that is in in clock is, see, whatever time which is taken in a system to execute the program, right? So if you say a time taken to execute the instruction is basically calculated in this clock period, right? Or clock time period, you can say, right? So how many clock time period is required with for the execution of that instruction is given by this clock as well, right? So it basically finds on T state. What, how many T states are required to execute that instruction, right? This is also important in case of your exams, right? हे टी स्टेट मध्ये मेजर करतात, हे सुद्धा गेटला वगैरे विचारलं, हाऊ मेनी टी स्टेट्स आर रिक्वायर्ड फॉर दिस इन्स्ट्रक्शन अँड ऑल, राईट? त्या काय आहेत ते आपण जसं सिलेबस येईल त्यावेळेस मी तुम्हाला सांगत जाईन, बट दिस इज ऑल्सो इम्पॉर्टंट पॉइंट इन केस ऑफ क्लॉक, राईट? So you can measure the processing time of any instruction in this T state, right? So each and every instruction requires few T state to execute an microprocessor, right? This is also an important part in microprocessor. Clock clear झालं का? Okay. Now, next term is tri-state logic. Right. Every time if you refer few books or documents, there is a terminology which is used is called tri-state logic. This microprocessor works in tri-state logic. Tri-state logic म्हणजे काय, तर टोटल 3 स्टेज आहेत लॉजिकच्या ज्याच्यात सॉरी मायक्रोप्रोसेसर वर्क करतात. वन इज हाय स्टेट, then low state, and third which is called as high impedance state. माहिती आहे का हे काय आहे? हे काय आहे माहिती आहे का? Okay. So high state obviously means high. High म्हणजे काय? One state आहे ती, right? In case of logic, right? Low state म्हणजे काय? Zero. हे तुम्हाला कदाचित लक्षात येईल की झिरो स्टेट मध्ये डिव्हाइसेस असतात. इम्पॉर्टंट इज व्हॉट इज हाय इम्पेडन्स स्टेट. आता हाय इम्पेडन्स स्टेट म्हणजे काय? तर या केसमध्ये in this state, no, all devices have signals over there. म्हणजे सिग्नल्स असतात, but they are electrically isolated. Electrically isolated or isolated means what? The signal is there, but it cannot work on that signal. A microprocessor does not work on that signal. म्हणजे काय, तर समजा मी डेटा पाठवला, ही डेटा लाईन आहे आणि याच्यावर मी डेटा पाठवला, समजा डेटा काय पाठवला 0110001, राईट, आणि तो पास झालाय नाही झालाय हे कळत नाही, राईट. सो या केसमध्ये लो स्टेट मध्ये असेल, जरी हाय स्टेट मध्ये असेल, स्टील इट इज कन्सिडर्ड ॲज हे डिव्हाइस कडून मायक्रोप्रोसेसरला पास, स्टील इट इज कन्सिडर्ड ॲज की याच्यावर काहीतरी डेटा आहे. सो या केसमध्ये मायक्रोप्रोसेसर काय करतं की हे सगळं सिग्नल हाय इम्पेडन्स मध्ये टाकतं, राईट. हाय इम्पेडन्स म्हणजे बेसिकली आता हाय म्हटलं तर मी 1 म्हणेन, की 1111 करून टाकतं एका टाइम स्पॅन साठी. अँड मायक्रोप्रोसेसर डज नॉट यूज दॅट डेटा since it is high impedance signal. That means it is electrically isolated. म्हणजे हा डेटावर मायक्रोप्रोसेसर काम नाही करत जर सगळीकडेच 1111 आले. आता हाय इम्पेडन्स स्टेट मध्ये असेल इन दॅट केस, राईट, आणि तो फॉर सम टाइम स्पॅन or some time period it will become again in its normal state, right. जो काही डेटा असेल तो कॅरी करतात. So if it is difficult to identify data on buses, then in that case, or in few operations, it puts in high impedance state, right? म्हणजे काय त्याला 1111 करत असेल, right? So 111 करतं म्हणजे काय तर त्या केसमध्ये त्याला काही वेळासाठी मायक्रोप्रोसेसरला काय करतं की you need not to work on that data, right? So this is basically a high impedance state case of tri-state logic. इथपर्यंत समजलं का? काही प्रॉब्लेम? Okay. Okay. Then next point is evolution of microprocessor. Rather, मायक्रोप्रोसेसरचं इव्होल्युशन कधी स्टार्ट झालं हे आपण बघणार आहे. सो याच्या आधी अबॅकस वगैरे या सिस्टीम होत्या, राईट, which is uh, used for calculation, right. So हे हे ancient cases मध्ये होतात की abacus system, right. In that case, that abacus system is used for calculation, right. त्याच्यानंतर ते कॅल्क्युलेटर्स वगैरे आले बेसिकली 1940 अँड 50. हे जे इयर स्पॅन होतं त्या केसमध्ये हे कम्प्युटिंग मशीन्स आले, राईट. कम्प्युटिंग डिव्हाइसेस यू कॅन से, राईट. ते स्टार्ट computing devices in this era, right. 1940s and 50s या केसमध्ये ते आले. सो मग त्याच्यात सुद्धा मग काय व्हायला लागलं, ज्यावेळेस इनिशियली दोज डिव्हाइसेस दे स्टार्ट विथ नो दे आर कम अप विथ रिलेज अँड व्हॅक्यूम, राईट. सो व्हॅक्यूम ट्यूब्स वगैरे याच्यात यूज केल्या आणि रिलेज यूज करून कम्प्युटर डिव्हाइसेस तयार केले त्यांनी. इन 1960s, सॉरी, 1960s they have come with transistors and all, right. ट्रान्झिस्टर्स वगैरे इन्व्हेंट झाले आणि त्या केसमध्ये याच्यात ऍडिशन झाले, राईट. कम्प्युटिंग डिव्हाइसेस मध्ये ट्रान्झिस्टर्स असतील किंवा सॉलिड स्टेट इलेक्ट्रॉनिक्स असतील, दे आर ऍडेड इन टू दिस कम्प्युटिंग डिव्हाइसेस, राईट. सो ही त्याच्यात ऍडिशन होती. अँड फायनली they are come up with ICs or integrated circuits. They made up integrated circuits and these computing devices again are computing devices again what we say have their additions, right. So त्याच्यात ICs वगैरे ऍड केले. मग हे ICs वगैरे आल्यानंतर मग बाकीचे हे जाईंट जे होते दे आर come into picture. So in 1970, or you can say in 71, right, to be specific, right, in 71, Intel come up with 4004 processor, right. In 1971, Intel come up with 4004 microprocessor, first microprocessor, and it is 4-bit microprocessor, right. They come up with 4-bit microprocessor, right. So त्याची वर्ड साईज असेल, लोकेशन्स असतील, हे सगळं 4-bit होतं. And they have their own different instructions are called or instruction set, and those are total about 45 or 40 plus instructions are there for this Intel microprocessor 4-bit, right? So this is the first microprocessor. Then in 1973, 71 to 73, they are in again a development. So they come up with PMOS technologies or PMOS technologies, and which is used for low cost, and some speed is there which is added. So that is basically a 4004 bit processor. So it is to be treated as what you say, a first processor which are there, or first generation processor which are there, and which is invented by what you say, Intel, right? Again, uh, there are few additions over there also. In first generation, we are talking about first generation. Right? So it is there in first generation. So 4004, then Intel 4040, then Fairchild TPS 25, National IMP 4, then Rockwell Triple P 4. All are 4-bit processor at that time in first generation. They also come up with Intel 8008. Then again, IMP is also coming with IMP 8, PPS 8, then IMP 16, sorry, IMP 8, sorry, IMP 8. Those all are again additions with 8-bit, right? So they come up with 8-bit ALU. So those are 8-bit processors. At first generations also, IMP has come up with, National IMP has come up with IMP 16, that is 16-bit processor in first generation, right? So this is all about, a first generation, wherein so many ICs are there, and those ICs are 16 bit. There are 16 pins available, which are there in first generation processor, right? And for 16-bit processors, they have come up with 40 pin, right? So in first generation, all those are 16 pins, and 16-bit has come up with 40 pin in first generation, right? So this is about first generation evolution in microprocessor. In second generation, yeah, come up with NMOS technology in 1973, which is basically offered high speed, right, uh, than the TTL compatible devices. So earlier there were TTL compatible devices or processors are there, or logic is there. So they come up with NMOS technology in second generation, and they come up with Intel 8080 processor, which is of 8-bit. Again, they have few additions over there, and they come up with Intel 8085 processor, which is also 8-bit. And this Intel 8085 is commercially successful processor by Intel, right? So Intel 8085 is a commercially successful processor which is from Intel, right? So for that reason, this processor is for study to all or engineering syllabus, right? So this is again 8-bit processor. So Motorola is also comes into picture in, you can say, in second generation. They are come up with M6800. Again, Motorola is has an addition as 6809. Then There are few processors which is called as Zilog is also uh, there as Z80 processor. So those all are again 8-bit processor, right? In this Toshiba is also comes into picture in second generation with Toshiba TLCS 12, which is basically a 12-bit processor, right? Then there are some 16-bit processors also available, that is WD AMCP 1600, then General Instrument CP 1600, then Data Generals UN601 is also a processor, and those all are 16-bit processors, right? Those all are 16-bit processors at that time. So this is all about second generation. What all characteristics of there as second generation? So the chip size is, or rather chip is of 40 pin in that case. So in 40, first generation we use basically a 16 pin for 8-bit and 40 pin for 16-bit. In second generation, they come up with 40 pins, right? So they have the ability to address more memory space with this second generation processors. We also address IOs, or rather other input output devices more than first generation. It has more powerful instruction set than first generation, right? So interrupt handling capacity and all are there as well, right? So this is all about second generation. Third generation, which is basically they come up with this third generation is in 1978, which is HMOS, right? HMOS is high density, you can say, right? So they are come up with has high density MOS technology with 16-bit processors, 16-bit processors in third generation. What all processors are there? 886 is there, 808 is 88 is there. Then Intel is there only in this uh, race in till third generation. So why? Because they are come up with commercially successful processor 8085. Then they added so many additions over there. So they are come up with 80186, 80286 there. Then Motorola is also there. Motorola comes with 68000 and 68010 chipsets, right? So such microprocessors are also present in third generation there with HMOS technology, right? So what is basic difference in this is they provided with 40 pin, they come up with 40 pin ICs, 48 pin ICs, 64 pin ICs, right? So processing capacity is higher than second generation. Obviously, speed is also higher than previous generation. It also has, capacity increased, right? So register basically is of 8 or 16 bit in earlier generations, but this third generation come up with 32-bit size of register, right? So that is addition over there, right? Interrupt handling capacity is also added. IO or input output addressing mechanism is also higher than previous generation, right? So this is all about third generation. Now, what is fourth generation? They in fourth generation they come up with HCMOS, right? Technology, which is what basically highlights in that is low power consumption, right? in fourth generation, they have come up with low power consumption versions, right? And with 32-bit processors. So power consumption, 32-bit processors, they are come up with. What all processors are present over there? 80386 processor, 80486 processor, those are all by Intel. Then Motorola comes with 68020, right? And 68030, right? And fourth generation with 32-bit processor, right? With 32-bit processing capacity, right? So those all are 32-bit processor. What all characteristics are there? Obviously, physically, memory space is larger than, or it addresses larger memory space than previous generation. You can have virtual memory space which is added over there in fourth generation, right? So it also supports, few addition. It basically addresses more memory, so it addresses addressing modes are added over there in fourth generation, right? So this is basically 80386 and 80486 processors are there in fourth generation with 32-bit processing capacity. And in fifth generation, which is fourth generation is there in uh, 1980, right? And fifth generation, they have come up with the fifth generation in 1993, right? What is basic difference is they introduce Intel Pentium processors in this fifth generation, right? So 8056 जी series होती ना, तिथून जनरली त्यांनी काय केलं की पेंटियम हे नाव ठेवायला चालू केलं. सो इंटेल पेंटियम प्रोसेसर rather Intel Pentium processors they introduced in fourth generation, right? Sorry, fifth generation. What is increased? Obviously, clocks. There are few additions, right? आता या प्रत्येक जनरेशन मध्ये ऍडिशन आहे म्हणूनच तो इन्व्हेंट झालाय. आता यात काय केलं त्यांनी पेंटीएम मध्ये जी प्रोसेसिंग कपॅसिटी त्यांची होती ती होतीच. फक्त याच्यात काय तर सेमी कंडक्टर जी technology होती, that semiconductor technology is improved in this. Also, clock speed is increased, right? Clock speed increased, clock speed मिळायला लागलं त्यामुळे operating frequency वाढली, right? Which is of 3.2 gigahertz and this, right? So operating frequency वाढली from 60 megahertz to, or you can say 60 megahertz to 3.2 gigahertz इतक्या लेवलला तुम्ही ऑपरेटिंग फ्रिक्वेन्सी ठेवू शकता इन केस ऑफ पेंटियम प्रोसेसर्स, राईट? सो तो इम्पॉर्टंट आहे. याच्या आधी इन्स्ट्रक्शन ज्या होत्या, राईट, म्हणजे काय तर 885 ज्यावेळेस इन्व्हेंट झाला होता, दे आर कम अप विथ 0.5 MIPS. That means million instruction per second, right? Million instruction per second. But at this fifth generation, they come up with 200 MIPS. That means 200 million instructions per second. They are come up with on 1 gigahertz frequency, right? 1 gigahertz on 1 gigahertz frequency operating system operating frequency. At that operating frequency, they have come up with 200 billion instructions per second in Pentium processors, right? So that is few additions were there in fifth generation, right? So Pentium processors are there in fifth generation. So what all applications were present over there in what we say in first generation to fifth generation. So in first generation, we have a calculator. We can build a calculator and game machines we can have. Then accounting system we can have. Uh, Special purpose applications we can build with those processors. In Second generation, we started complex industrial controllers, then communication preprocessors we started. We have process control systems, right? Then we have intelligence terminals, military applications we added in second generation. Then third generation, we have business and data processing applications, then advanced communication systems added, then distributed processing, what we say, distributed processing networks. We provide power to distributed processing networks in third generation. In fourth generation, general purpose computing applications are there, user multifunction environment we can have. Then we can offer so many information equipments with those processing capacity. So those all are applications till fourth generation. Now you are in fifth generation of what we say processing, computer processing, right? So you know all applications which are there presently available to you, right? So this is all about evolution. They started in, I think, they started in 1940s. They come up they come up with first processor in 1970s. Until now it's going on, right? So this is all about, how microprocessors are evolved, right? इथपर्यंत क्लिअर झालं का हे सगळं इव्होल्युशन काय आहे? इथपर्यंत क्लिअर झालं का? आहेत का तुम्ही सगळे? Okay. So we'll stop for today.